Hello friends, welcome to Legend Lens, and today we're going to have a look at graphical representation of complex numbers. Okay, so although we cannot evaluate a complex number as a real number, we can actually represent it diagrammatically. Okay, so this diagram constitutes what we call the Argand diagram. Argand diagram. And when we use these examples to illustrate how we actually represent complex numbers graphically. Now, what you should know is that the unit I actually turns a vector through 90 degrees anti-clockwise. It actually turns a vector through 90 degrees anti-clockwise. Now, this is what it stems from. When you have this nice graph over here, there should be one. This is 3. So now, when you multiply 3 by negative 1, that's 3 by negative 1, this is going to give us negative 3. And this actually turns the vector through 180 degrees anti-clockwise. It turns it through 180 degrees anti-clockwise. That's what it does. 3 here multiplied by negative 1 gives us negative 3. What it does is that it turns this vector, which was initially here, 180 degrees to the other side of it. Now, we said negative 1 here is the same thing as I squared. So I squared is the same as negative 1. So if I squared is giving us 180 degrees, then what will I give us? It will obviously turn it through 90 degrees. So that's basically how it is. Now let's get back to this way, graphical representation of complex numbers. I'm going to use this example. Alright, so let's start. Now, I have this nice graph over here. You notice the y, this x. Now, the x here becomes the real part. Okay, this represents the real part of the complex number, and here becomes the imaginary part. So this axis is sometimes called, or it is called, the real axis, and this becomes the imaginary axis. As simple as that. Real axis, imaginary axis. So now let's see how we represent the numbers. That's the complex numbers. Alright, so we start with z1. So z1, the real part is 2. So you pick 2 on the real axis, which is this side, and the imaginary part is 3. So that is where we get a point. And then you draw a vector from the origin to the point. Just as simple as that. So this becomes z1, which is equal to 2 plus 3i. That is it. So we are done with A, which is z1. Now with z2, which is negative 3 plus 2i. Negative 3 on the real. So neg 1, neg 2, let's say here be neg 3. Then 2 on the real, imaginary axis. So you can actually have a draw a vector to that side. So, and this becomes your z2, which is negative 3 plus 2i. Then the last part, which is negative 4, negative 5. So negative 4 on the on the rear, the negative 5, let's say negative 5, let's say it's at this side. So you draw, yes, so that is how we represent V. Oh sorry, it's left with 1 over here, which is a C. We haven't actually done this one, so this is actually Z4. Actually Z4, which is Z4 being equal to minus 4 minus 5i. So 4 minus 3i. So 4 on the rear, the negative 3. Let's say it's actually here, negative 3 on the imaginary axis. So that becomes Z3. Yeah. Alright, so this basically how we represent complex numbers graphically. So this diagram is what we call the Argand diagram. Argand diagram. Thank you guys. If you really enjoyed this video, just subscribe for more videos. Thank you.